Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here, and we're going to be going over the Unit 7 review, which is our statistics unit. Should be a pretty quick one because I feel like you guys have pretty much been crushing this whole unit, but let's jump into it, okay? You guys would like this is my workout headband to cover up the shine on my forehead this time around. All right, so let me go ahead and get myself out of the way and let's get moving here, okay? So the first thing we're going to be talking about here is the mean, median, mode, and range, also known as measures of central tendency. And in example number one, what we're looking at is there's a number of goals that have been scored. And so when we look at this, it's given us how many times it actually occurs. So for number one, when we look at it, we're saying that 0 goals were scored 2 separate times. So the long way of looking at this is like saying 0 goals were scored 2 separate times. The next thing is saying that there is 1 goal that gets scored, but this happens 3 separate times, so over the course of 3 separate games, like this. The next thing would be that there are 2 goals, and those are scored 5 times. 1, 2, 3, 4, 5. And then the next one would be that 3 goals were scored 2 times, so 3 is happening twice. And then 4 goals were happening 3 times. And then after that, 5 goals happened only 1 time. So when we look at this data, what we're supposed to be doing is to find the average, we have to add up all of these numbers together. And then from there, we're going to add up how many times it actually does occur, or how many different games took place. And so when we look at the number of games that took place, we can add all those together right here, and there are 16 games that took place. You can see that there are 16 data points here. If I'm going to go through and sit here and add all these together, I can really just take and multiply these together. So like if there's 0 happening twice, 2 times 0, right? If I have a 1 happening twice, this is like 1 times 3. If I have a 2 happening 5 times, this is like 2 times 5. And so I can keep doing this throughout the whole thing. So then what happens is if I just multiply each one of these together, that's going to give us the total number of goals that were scored, which in these cases would be 0, 3, 10, 6, 12, and 5. And if I take all of these and add these together, this will tell me the total number of goals that were scored. So there are 36 goals that were scored. So to find the average number of the average number of goals that were scored, we just take all of that we added together and we divide it by how many there were. So there are 36 goals scored. There were 16 games that this happened over. So 36 divided by 16 means that we have 2.25 goals per game. Okay. The median of this, remember, is always the middle. And when I look at the fact that there are 16 occurrences happening, well, the middle of 16 is between 8 and 9. So if I look at 1, 2, 3, 4, 5, 6, 7, 8, and 9, so it's these two right here, 8 and 9, you can see that we have the same number happening twice there. Both the 8th term and the 9th term are 2, so the middle of this is still going to be 2. The mode, remember mode means the most frequently occurring. And so we look at the occurrence, which happens 5 times, and that happens to be when there are 2 goals getting scored. The range is when we take the highest value minus the lowest number, or the max minus the min. And the most goals that were scored were 5 games. The lowest amount was 5 goals in the game versus 0 goals in the game. So 5 minus 0 means that 5 goals was the range that took place for this. Okay? All right, cool. Let's move on to number 2. Number 2 is talking about the weekly grocery budget. This is a family aims to spend on average of $145. So that's the goal. We're trying to get an average of $145. So what that means is that when we take all of our data and we add it all together and we divide by all of the weeks, this is the number that we should end up with. They're trying to average 145. So some weeks are going to be higher, some weeks are going to be lower. If we look at the data here, they say that during the first 3 weeks, this first time they went under budget, right? They were under, so they were at 138. The next one, they were over, and then the next one was under. The question is, if there's 4 weeks in the month, how much should they spend in that 4th month so that all of it averaged out to 145.50? Well, when we're finding average, remember, we're going to add each one of these values together, and we're going to divide by 4. Well, I don't know what that last value is, so let's set it up. If I take my last value, which is unknown, and I add the other 3 to it and divide it by 4, we have this equation. To get rid of this 4 that we have happening here, the opposite of dividing by 4 is to multiply both sides by 4. That's going to cancel out these 4's that are right here. And so what we're left with is x plus $430.75. That's how much money they've spent so far. And then we're going to take that and we're going to subtract that from 582, and they're left with $151.25 to spend to stay within their average budget. Okay. All right, cool, easy stuff. Let's move on to some probability stuff, okay? For example number 3, or problem number 3, it says we're going to do the perfect roll. So it says a single standard 6-sided die is going to be rolled. What is the probability that the number rolled is either a prime number, which is 2, 3, or 5, or is a number 6? Well, when I roll the dice, it's a what's probably it's going to be a 2, 3, or 5. That means that there's 3 outcomes right there, a 2, a 3, or a 5. Those are the 3 possible outcomes right there. If I say that it's going to be a 6, there's another outcome right there. So it's 4 outcomes that are possible out of the 6. So it's going to be 4 out of 6, which is 2/3. So that's basically a 67% chance that if I roll the dice, I'm going to roll one of those numbers. Okay. All right, coin and die problems, very famous one. Flipping a coin and then rolling a dice, okay? It says for part A, let's go ahead and draw a tree diagram to show all the possible outcomes and then how many are there. So here's the first one. I take a coin, I go ahead and flip the coin, right? It's going to come up one of 2 ways, heads or tails. In this first scenario, let's go ahead and say it comes up heads. Now, after it comes up heads, I'm going to roll a dice. And when I roll the dice, it can come up a 1, 2, 3, 4, 5, or 6. So what are all the possible outcomes? This is what a tree looks like. We take all the possible outcomes, we match them together. So if I go heads and then 1, or heads and then 2, or heads and then 3, and keep doing this, these are all the possible outcomes. Head 1, head 2, and so on and so forth. What if it came up tails first? Well, if it came up tails first, it would be a tails and then a 1, or a tails and then a 2, and then a tails and 3. So these are all the possible outcomes. So when we look at all the outcomes here, there are 6 here and there are 6 more here. There are a total of 12 possible outcomes that we could have gotten. Now, if I use the fundamental counting principle, I could have said for the coin that there's 2 outcomes, and for the dice, there are 6, and together there are 12 possible outcomes. Okay. So now using this information, it says, what is the probability of landing the coin on heads? And then I roll the die, and it has a number showing a value that's greater than 1. Well, if it's going to roll heads, it's going to come up heads first. That means we are looking at this scenario right here. It's coming up heads. And then it says the die is going to show a number that's greater than 1. Well, there's 1, there it comes up heads, and then there is going to be 1, hang on. Heads, and then there's 1, 2, 3, 4, 5 numbers that are greater than 1. Okay, so there's 5 there. So that means that of these scenarios here, when we look at this, these are the 5 possible ways. Of all the 12 possible ways that I can get this to happen, there's only 5 that would come out heads and then a number greater than 1. So it's 5 out of 12. Letter C, what is the probability of the coin landing on tails and the die showing a 2 or a 5? Well, if we're forcing it to be a 2 or a 5, there's only 2 possible outcomes, right? It can only be a 2 or a 5. So what's the probability that's going to be a coin landing on tails over here, and then it's going to come up a 2, or it's going to come up a 5? So there's only 2 possible ways that this could happen out of 12, which means it's a 1 out of 6. All right, let's look at compound events, and this is with replacement. So what this means is that I'm going to take and replace the object. I'm going to literally take it out, and then I'm going to put it back in. Okay, so let's kind of see what this ends up looking like. A bag is going to contain 8 red marbles. So I got 1, 2, 3, 4, 5, 6, 7, 8. I've got 4 blue marbles, 1, 2, 3, 4. And then I've got 3 green marbles, so I've got 1, 2, 3. Okay, and so when I look at this, there are a total of 15 marbles that are happening in this scenario. Now the question is, what's the probability that I'm going to draw first a blue marble, and then after I take it out, and I'm going to put it back, and now my second one is going to be a green marble? Well, look at the blue marbles. Of the 15, there's only 4 that are blue. So there's a 4 out of 15 chance that I grab a marble. So let's say I go ahead and grab this one, it's gone, but then I put it back in, now it's back in the mix. In this case, then, my next marble that I'm going to grab is going to be a green one. Well, there's 3 green ones, so it's going to be a 3 out of 15. Multiply these across and simplify them. It is a 4 out of 75 chance that I'm going to draw a blue and then a green. Now, let's talk about the same scenario, but this time what we're going to do is we're going to take this, I'm going to duplicate this, and we're going to move this down here. This time it's going to be there's no replacement in this whatsoever. Well, there's still 15 marbles. So the question is asking, what's the probability that the first one's going to be blue, and then the next one is going to be a green? Well, let's look at the blue opportunities first. Of the blue ones, there are 4 out of the 15 marbles that are there, so there's 4. Now, I'm not going to replace it. So what that means is I'm going to go ahead and now it's removed, it's gone. I've taken a blue one, it's not there anymore. So now the question becomes, all right, well, what's the probability that I'm going to draw a green for the next one? We can see that there are 3 greens here, but now we don't have 15 marbles anymore. I took away this one that was right here. So now there's 3 out of 14 marbles that are green. And if I multiply these together and simplify it, it's a 2 out of 35 chance that I'm going to get that exact combination to happen. Okay? Let's start over again. Let's talk about the next problem. What is the probability that I'm going to draw 2 greens and there's no replacement? Okay? All right, well, let's look at this. So we look at the greens. There are 3 greens here. So the first marble that I'm going to draw has to be a green. So it's going to be 3 out of 15. Now let's say I got lucky. I grabbed the green. It's out of there. Now, how many greens are there remaining for me to grab from the mix? Well, now there's only 2 greens there's 1 less marble. So it's a 2 out of 14. Multiply these out and simplify them. We end up with 1 out of 35. So that's pretty cool. All right. Problem right here that's pretty cool, in my opinion, because, me being a bowling coach, I appreciate this question. So most professional bowlers score strikes on 58% of the frames they bowl. Leave following as percentages. So letter A, it says, what is the probability that a professional bowler is going to get a strike on the first frame and on the second frame? Well, the probability to get on the first frame is 58%. And then it says right here in the problem that they can get a 58% on any frame that they bowl. So then it's going to be on the second frame also a 58%. So if we multiply these together, it's 0.3364, which is going to be 33.64%. Okay, so that means that they're going to get on the first frame and on the second frame. The probability of this happening is only 33.64%. So then the letter B is, well, what's the probability that a professional bowler does not get a strike on the next frame? Well, it's a 100% chance of getting, just in general, it's a 100% chance of them throwing a ball. There's a 58% chance that they're going to get a strike on this. So if they are going to get a strike 58% of the time, they're going to not get a strike 42% of the time. Okay, so we just subtract those. All right, let's look at the next questions, and then we're moving on to permutations, combinations. All right, so let's take a look here. It says, how many ways can you select a group of 12 students 4 at a time? So it's really important to know when we're dealing with these problems whether the order matters or it doesn't matter. If the order matters, we have to look at this as a permutation. If the order does not matter, it becomes a combination, okay? And you can see some examples up here of when an order matters, what it's like, and when the order doesn't matter, what it's like. And there's certain words to look for. So like when we say permutation, we're talking about words like arrange, order, rank, position. And when we say combination, we're talking about making a group or like a committee or choose or things like that, okay? So let's take a look at letter A, or number 8. It says, how many ways can you select a group, select or group 12 students 4 at a time? So if I had, just to put this in perspective, if I have a student A, B, C, and D, and then I had student A, D, B, and C, isn't this the exact same group? It's just that they're rearranged, right? So the order here doesn't matter. And so what we say is that there's 12 students. I'm going to choose 4 of them. That means that there's 495 ways that I can go ahead and choose a group of 4 from 12 students. Okay. For number 9, how many ways can you arrange? Well, where there's the word arrange, and it means that the order does matter. So that means it's going to be 12p4. And so throw this in, we're going to have 11,880. Okay. And we should always notice that combinations are always going to be smaller because ABCD is the same as DBCA versus in a pure permutation, those are two completely different things. Okay. For number 10, this one's a look weird when you first read it, but not too bad. So we're going to make a 4-letter number, symbol, password. So it's going to have 4 characters in it. It could either be a letter, a number, or a symbol. There are 10 numbers to choose from. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a total of 10 numbers, including 0. That's why. There's 26 letters. And there are, when you look at the characters, there are 1, 2, 3, 4 characters that we could choose from. So there's a total of 40 things that I can actually choose to use for my password. And it's going to be a 4-digit password. So that means I'm going to have 40 that I can use for that first spot. I'm going to have 40 that I can use for the second spot. I'm going to have 40 that I can use for the third spot. And I have 40 for the fourth spot. So that means I have 2.56 million different possible passwords that I can make. That's only 4 digits long if I have all 40 of these options to choose from. That's a lot. Okay. All right, how many ways can you pick a president, vice president, secretary, treasurer from 15 candidates? In this case, the order matters. Why does it matter? So think about it. If we have person A, we'll use A, B, C, and D again, right? There's 4 people in this situation, right? Any one of these 4 people can become the president. So we'll just go ahead and pick this person. We'll make them the president now. Well, now that they're the president, they can't be the vice president. They can't be the secretary anymore. So the order that they get picked matters. So in this situation, though, we don't have simply just 4 people. We have 15 people that we're choosing from. Well, 15 people can be the president. Now that person's the president. They can't be anything else. So now there's 14 people that could be the vice president. From those 14 people, I'm going to pick one person. They're going to be the vice president now. So if we had 15 people, one's the president, one's the vice president. Now there's only 13 people that could be the secretary. And then 12 people that could be the treasurer. So there's going to be a total of 32,760 ways that we can choose those 4 positions if there are 15 people. All right. Last question here, number 12. How many ways can you arrange the letters in the word milliliter? Well, in this case, order matters because when we look at this, we have an L here and an L here. There's 3 L's going on here. If I rearrange those, I can't tell that I rearranged those. So we call this a distinguishable permutation. And the formula for this, if you remember, is up here. It means N, where that's the total number of all the letters that are being used. N1 is the first letter. N2 is the second letter, and so on and so forth. So when we look at milliliter, there are 1 M, 3 I's, 3 L's, 1 T, 1 E, and 1 R. And there are a total of 10 letters in this entire word. So if we set up our formula, there's going to be a 10 factorial on the top. We're going to do, for the next value, we're going to do 1 factorial here, 3 factorial, 3 factorial, 1 factorial, 1 factorial, and 1 factorial. Now it's important to remember those 1 factorials, you don't need them. Remember 1 factorial by definition is equal to 1. So it doesn't change the problem, so there's really no point in doing it, but I put it there just so you can see it. If we go ahead and simplify this, we get 100,800 different ways that I can arrange the letters in the word milliliter. All right, let's continue on. Coach Shweta has 2 freshmen, 2 sophomores, 5 juniors, and 7 seniors. How many ways can he select 4 team members for a relay? So he's just choosing from these 4. He's not saying that the order matters. He's saying, I'm just going to pick 4 kids from this group. Well, when we look at the total here, there are 2, 2, 5, 7. There are a total of 16 kids that I can pick, okay? And there is a 4-team member. So that means I have 16 athletes. I'm going to do 16, choose 4 of those, and there are going to be only 1,820 ways that I can choose a 4-person relay team from those options. So now let's look at a different situation. Shweta has 2 freshmen, 2 sophomores, 5 juniors, and 7 seniors. He may, and I'm sorry, how many ways can he select 4 team member relays if he's going to pick? Now, this is, he's changing it. He has to pick 1 freshman, he has to pick 1 sophomore, 1 junior, and 1 senior. So what that means is that from the 2 freshmen that are there, he's going to choose only one of them. Okay? And that's going to equate to the number 2. From the sophomores, there's 2 sophomores, he's going to choose only one of them. From the juniors, there's 5, he's going to choose only one. And from the seniors, he has 7, he's going to choose only one. So using the fundamental counting principle, we really get 2 times 2 times 5 times 7, which is a total of 140 different ways that he can come up with the team. Okay? All right, number 5, Mr. Jones is opening a sandwich shop. He is going to be offering sandwiches that are going to, there's 4 kinds of breads to choose from. There's 6 kinds of meat, 3 veggies, and 5 kinds of cheese. So for the breads, there's 5 different kinds of breads. I'm sorry, 4 kinds of breads. There are 6 kinds of meats. There are 3 kinds of veggies, and there are going to be 5 types of cheese. And you're going to be choosing one from each of these. So you could have said 4, choose 1. We're going to go 6, choose 1. We're going to do 3, choose 1. And then we're going to do 5, choose 1. Okay. The order doesn't matter because ultimately what's going to end up happening is like I'm going to have a sandwich. I could say, I can go up to the register and be like, I would like this meat, this veggie, this cheese, and this bread. Or I could have said, I want this bread, this veggie, this cheese, this meat. So the order that I'm presenting, it doesn't matter. But ultimately it's 4 times 6 times 3 times 5, which is only 360 different sandwiches. Okay. All right, Venn diagram. When we look at the Venn diagram here, we are talking about the fact that in this Venn diagram, and these are the toughest ones probably in my opinion, we're saying that in a league of 100 players, there are 40 players that are all-stars, 37 players that are 6'10", and there are 33 players that are not all-stars or over 6'10". So let's take all this information and kind of throw it into our diagram, okay? When we look at the diagram, you should remember that outside of the circles are going to be the neithers. This circle right here is where we're going to have the all-stars. This circle right here is where we're going to have over 6 feet 10 inches. And in the middle here is where we're going to end up with both. Okay? So let's start with the easy part, the neither. We know that when we look at this, there are going to be, as it says here, 33 players are not all-stars and they're not over 6'10". So that means that there are 33 that are neither. So now mathematically, what this tells us is that from the 100 students, from the 100 players, if 33 are neither, that tells us that 67 people are one of these. If there's 33 here, then that means that there has to be 67 inside of this area total. Well, when I add these together, 40 and 37, which is supposed to fit here and here, 40 and 37 adds up to 77. But I'm supposed to only have 67. So what this tells us is that there's an overlap taking place here, that I have used a number more than once. Well, what's that difference? Supposed to be 67, I've got 77, that means I used 10 twice. Okay? And so that's how we find out what that middle value is. So now let's finish piecing this together. There are supposed to be 40 over here. I've got 10. That means that 40 minus 10, this is going to equal 30. There are supposed to be 37 over here. I've got 10. So the remaining part right here has to add up to 37, which is going to be 27. Now that we have all the parts of the Venn diagram, let's go ahead and fill in all the missing information. So all the questions. So if one player is chosen at random, what's the probability that they are on an all-star and are over 6'10"? Well, here's the over, here's the all-stars and here's the over. And the overlap here is that there's 10, so it's going to be a 10 out of 100 people, which is a 10% or 1 out of 10. If 2 players are chosen at random, what's the probability that both players are not all-stars? Well, when we look at this, they're not all-stars. These are the people that are all-stars right here. The people that are not are these guys right here and these guys right here. These guys are not all-stars. So that means from the 33 and 27, there are a total of 60 people that are not an all-star. Okay? So then when we look at this, it's 60 out of 100. Now I go ahead and I pick this person. They're not in the mix anymore. So I can't choose them anymore. So now there's not 60 people to choose from. Now there are 59 out of 99 people to choose from. And so we put this together at 3540 out of 9,900, which is a 35.7% chance. Question is on the letter C, what percentage are under 6 feet 10 inches? Well, these are the people that are over 6 feet 10 inches. And we know that there are 37 players that are over 6 feet 10 inches. So that tells us that if I do 100 minus 37, that there are going to be 63 people that are going to be under. So it's going to be 63%. Okay? All right, let's look at a pie chart. There's 850 18-year-olds who were surveyed in northern Cook County about their hourly wages, and is shown in the pie chart below. If a person is selected at random, what is the probability that they will earn at least $17.51? At least $17.51 means that they're going to earn $17.51 or more. Well, these guys right here are earning $17.51 or more, as are these guys right here. So if we put these together, there are a total of 20 and 45, or 65%, or 13 out of 20. How many we earn $25.01 or greater? Well, when we look at this, there's 20%, or we're going to fit in that. So what we have to figure out is what's 20% of the 850 people. So 20% of 850 is 170 people. Letter C is how many will earn $17.50 or less. So $17.50 or less is 35% of the 850. So we'll figure that out. That's going to be 297.5 people. But when this happens, you can either round to 297 or 298. Either one's going to be pretty much acceptable here. Okay. But there we go. All right, and the last question are matrices. I color code this whole thing so you should be able to follow all the colors. But what's happening in letter A is we're taking the two matrices and we're subtracting them. So that means we're going to take letter A and we're going to subtract letter B from it. So we're going to take the 9 and we're going to subtract 12. And then from there, we're going to take 6 and subtract 9. And so matching all the colors up, 9 minus 12 gives me negative 3. Okay. 6 minus 9 gives me negative 3. Negative 3 minus negative 3 is going to give me a 0. 2 minus 15 gives us a negative 13. 0 minus 0 gives us 0. And then last one, 5 minus 6 gives us a negative 1. Okay. Part B is a little bit tougher. This is a multi-step problem. We have to figure out what twice A is first. We have to figure out what 1/3 of B is, and then we have to take them and add them together. Okay. So if I take twice of A, that means take all the values that we see in A and just double it. So that means we're going to have 18, 12, negative 6, 4, 0, and 10. For letter B, it says we're going to take 1/3 of that. What that means is we're going to take each value in B and we're going to divide it by 3. So 12 divided by 3, 9 divided by 3, and so on and so forth means that we end up with this matrix here. So then if we take all these and add these together, we're going to have 18 plus 4 is 22, 12 plus 3 is 15, and so on and so forth. Okay? And here's the last question that we're going to have. This is determining values of x, y, and z from the matrix. So basically what we have to do is just go through and look at where they are positioned at, take all the parts that come along with it, and then we can use that to solve. So when we look at this, we have a negative 2 on the outside of only this matrix right here. Some of them you'll see where there's a parenthesis around the whole thing, but in this case there's not. It's just in front of this first matrix here. So we have a negative 2 multiplied by 3x, then we're going to add a negative 2, and that's going to equal a 2 times 20. Right? We're using all the stuff that's in the positions and in front of it. So that's going to be our first matrix that we're going to have. The negative 2, the 3x, the negative 2, and then 2 times 20. Set up the equation and solve. We get that x is equal to negative 7. Let's do this again. This time let's go ahead and do it for the green stuff here. So we're going to take the negative 2 and the 8 plus the 2z, and that's going to equal 2 times 10. And there's your second equation that we're setting up. And for the last one, we're going to have negative 2 times 2 plus 4 is going to equal 2y. set that up over here, and then solve for y. And that is it. So I know I went fairly quickly through this, but feel free to go back and watch it at your own pace. If you can do all this stuff, you're in great shape for your test, okay? You guys take care, though. Let me know if you have any questions before the test. Otherwise, be safe, be respectful, be responsible. Don't forget to like and subscribe, and you have a wonderful evening.